The Earth has its own internal heat source from the force of gravity against the total Earth's mass. The heat is greatest in the center and radiates outward. The heat is insulated in the convection zones of the mantle, insulated further by the lithosphere and the continental crust, and the final insulation layer is the atmosphere. The sun shines on a little less than half the Earth's surface at all times. The Earth's albedo is variable, from very high, at snow or ice surfaces, to very low, as over the ocean. These variations, along with the gravitational pull of the sun and the moon, create differences in potential energy that drive movement in the water and air. Life's place in all this is significant. The characteristic that unifies all life is that life alone resists gravity. Life can pull down in water against buoyancy and can rise up on land against gravity. With procreation, this activity is sustained against time. Life does this by encapsulating water in a hydrocarbon membrane assembled in various levels of complexity. Life alters the thermodynamics of Earth relative to what would exist under the influence of gravity and sunshine alone by removing carbon from the air and depositing it on the crust in a mineral form. This is a one-way transaction. Yes, it comes with many belches of carbon into the atmosphere and even forest fires that emit carbon and heat. The overall trajectory of carbon through life is from the air into the ground. That is, until the industrial age. Humans have been returning significant quantities of mineral carbon back into the atmosphere. This is commonly called anthropogenic carbon. There are many variables that affected Earth's climate from accretion to now. Examples of factors that we have no control over include Earth's orbital eccentricity and axis tilt, solar activity, and incident carbon flux. We know these fluctuate and show impact to climate over the deep past. However, we can affect climate by taking care of our ecological system's health. We can stabilize climate through ground cover. People have a catalytic role in the forest. Using knowledge of a few simple patterns and a few simple tools, we can sculpt our existing forests to facilitate the flow of carbon into the ground. On a large scale, this would include herd grazing that traverse all open spaces on a periodic basis of approximately once a year. This will fertilize and trample the soil and bring last year's dead material to the ground. People's ability to balance the trees will strengthen the forest and increase its biological output. Healthy forests are less prone to catastrophic wildfire. The anthropogenic geological event of releasing significant amounts of mineral carbon into the atmosphere has helped us learn a lot about the forces of nature to the point that we simulate life in inanimate objects. Instead of using this power of knowledge to enliven our living systems, we have been using it to simulate and replace the living system. We have cut down most of the land forests, dammed most of the rivers and tributaries. The biological system of Earth is experiencing a sharp decline in species and in activity. Without forest cover to cool the earth and condense water, the bare soil will heat up, warm the air, and evaporate water.